experiencing yesterday and the day before. So it seems like the streams are working okay. We got bandwidth back. I have no idea how. I can only determine it's a problem at the ISP level. I definitely needed to stream today because I'm going to hit you with a little bit of info that some of you guys might find daunting. But we'll take it slow. What? Right? So I'm going to introduce you guys. Oh, nice. Very cool. Nice concept art. I'm going to introduce you guys to some very, very basic concepts of rigging, or how do you create the puppeteering controls to move your character around. I'm going to build on what I taught you last time, right? So I'm going to pop into here and we'll find that character ball, right? File does not exist. Let's go and set our project. I may have migrated the project. I think that I did. There we go. Vis-a-vis documents. Let's set that project and we'll try and open that scene again. Inside my actors, there's our character, the bouncing ball. Okay. So yeah, any of you guys go ahead and try a little character animation with these guys? No. Okay. Yeah? All right. Cool. Now, I haven't taught you how to deliver this, so we'll be talking about that a little bit today. An attempt was made. Okay. How'd it go? Okay, that's cool. Cool. I did in Blender. Yeah, that's all right. That's fine as well. I tried but failed. Okay, that's cool. We'll talk about it today. Okay, that's cool. It's all good. Don't worry about it. We're going to have to try it again, except with something slightly different, right? Oh, so you know how to play blast. So if you want to throw a play blast into the group, or if you want to post it on F-Track, that's totally cool. Let me pop up. Let me make sure F-Track is set up for it. That might be a good idea, actually. So I'm going to pop over into F-Track, and we're going to take a look. And then I'm going to talk a little bit about some very important key concepts, right? All right, so level 4 games. Let's go in here. Again, you know, what I said to you at the beginning of the year, and possibly when I interviewed you guys for the course, is that part of the joy of 3D animation is also part of the frustration. And the joy for me is that you are now in a situation where you're marrying your left brain creativity with your right brain technical thinking. Now, what I love about it is 3D animation makes you use all of your brain, which will also be frustrating because generally I find that 70% of us that get into 3D animation are predominantly left brain creative thinkers, right? So being confronted with the more technical side of implementing 3D animation, we find that that side of our brain has atrophied somewhat. So there's a little bit of catch up to do in that regard. I have created a Creative Practice 2 F-Track area or whatnot, and I've posted what the coursework is. So I think, yeah, underneath the coursework, I'm totally okay for now if you want to just post your clips up there. Eventually, I'll be creating custom entries for each of you guys, right? But you can just chuck your clips up in here, right? Under versions, you can just drag and drop your play blasts inside of here. Knowing me, I'm still going to stick to 2D after this course, even if I do get a grip with 3D. Yeah, we all of us who have 2D as our background will most definitely stick to 2D. I am asking, begging, imploring you to really dive wholeheartedly in the 3D and sort of abandon the 2D side for at least a year and a bit, right? Because the 2D side of your creativity will operate as a crutch. Trust me, I have seen it happen countless times. It has happened to me as well. You get so frustrated with the 3D, You just jump into your Sketchpad and you don't bother opening a 3D package anymore. And that is bad. I have had a number of students who have gone through the 3-year program and at the end of the 3rd year just wanted to do a 2D animation cartoon. Pretty much involving nothing that they learned the entire 3 years they were here. So I don't want that to end up to you guys. It's almost worse if you're a good drawer, right? Because if you're a good drawer, it's the frustration is like magnified and you just don't want to dive into anything 3D. But, you know, you guys take my visual studies module, you know I'm a good drawer as well. I will try to introduce or make it comfortable for you because I know where you guys are coming from, right? As I introduce these 3D concepts. You got to sort of embrace it and relish it to a certain degree, right? The worst thing about 3D scaring you guys, I find with everybody, is breaking the ice, right? Just jump in and make errors. Make Maya kind of crap out. You know, that way you can figure it out a little bit more. I'd rather you be inside using Maya and making mistakes than just never opening it, right? Yeah, it's definitely like learning how to do art all over again. Absolutely, 100%. Yes, 3D art hurts you in the beginning, though. In the beginning. What about someone who wants both? I feel better in 3D and now I feel better anyway doing. That's fantastic. If you're comfortable in both, I've worked with some colleagues who are equally comfortable in both. You are lucky. You are lucky. If you're comfortable in 3D and comfortable in 2D, that's a wonderful place to be because it means that you're fascinated with the technical side and the creative side, right? Even after the beginning, I don't know why I'm so irrational from doing it. Yeah, I know. It's not... It's an incredibly artificial way of getting your vision on the screen. Whereas with drawing, you just pick up a pencil and you start drawing, right? There's that immediate connection to your creativity. Okay, I'm just going to jump ahead because I don't want to digress like I did last time. Now, our character rig, we spent a fair amount of time putting it together, right? So it's kind of cool. It's not the most sort of comprehensive rig. I'm going to switch over to my channel box, right? Because inside the channel box, remember I showed you guys how to add an attribute and we added the squash, right? Which is cool, but I want a little bit of personality in the ball. I want to be able to take it from just being a ball that simply bounces to making it a character that has a little bit of personality, right? So for example, if I wanted the ball to turn and look at you, right? Would I be able to do that? Well, I can take this ball, have him stretch up and go, huh? But I can't really make him turn and look at you, right? So I want to try and fix that a little bit, as well as the fact that the stretch, whoops. Why? My camera rotation seems to be locked. 1 second. Why is my camera rotation locked? Let me turn on my display grid, see if I'm oriented correctly. Oh, weird. Okay, my rotation's back. That was bizarre. Okay, so what I was saying before, there's a couple of things wrong with this rig. Deliberately so, right? It's good enough when you're doing the bouncing ball for the first time, but there are a few things wrong with it. So first of all, I can't get any more expression into that ball other than squashing and stretching along one particular axis. You know I can grab this guy and I can rotate. I can rotate the handle so I can get a little bit more sort of expression. But I'm pretty much locked into that. As well, I have to do what's counter animating, right? Does Maya need Windows 10? I don't know if 2020 needs Windows 10. Typically, Autodesk, when they create a Maya release, they ensure that it's compatible at least two operating systems back. Yeah, Windows 7 should be supported. 2020 should be supported. Yes, in Windows 7, it will likely use your CPU more than your GPU, if at all, I think. Oh yeah, you need to change it in your NVIDIA panel. That makes a lot of sense, right? So there are a few niggly things in Windows 10, Windows 7 that might not be operating quite as smoothly as in Windows 10. Okay, so counter animating. This is a really, really kind of important point. Counter animating is something you guys want to avoid. Counter animating is what riggers are always trying to avoid. So what is counter animating? Well, animating is bringing a character to life, moving them forward, having them perform. Counter animating is then fixing the pose or adjusting the pose where you're not really animating. The process of animating is about finding performance and moving your character into that performance. One thing I also want to specify is that kinetic motion does not equal animation. Does not. I've met loads of people, programmers, graphic designers, Flash guys who say, yeah, I'm an animator. And I look at their stuff and it's like, you got stuff moving around on screen, but buddy, that's not animation. Right? So what is animation? Well, in a nutshell, performance. Dramatic performance, right? So when you are moving your character and it's not for a dramatic performance reason, you're counter animating. So here's what I mean by counter animating. I'm grabbing this guy and I'm going, okay, it's going to stretch up, but he's off the ground. So I have to grab this and move this guy off the ground. Counter animating, right? And it's not a fault of you guys, it's a badly created rig, right? Because the rig hasn't taken into account that you might have to counter animate to get that ball to sit on the ground, right? There's two different options as well. I grab the root controller, but I could also grab this controller that has just my, okay, this is a good point. I can grab the controller that just has my deformer. Now here's the shortcoming of a deformer, right? So see what's happening here? Now, a deformer is like a force zone, right? So the ball is sitting outside the squash deformer force zone, and now I'm bringing the force zone in, and it's taking over and then out again, right? So, this is kind of cool. You can, with the fact that I've attached a controller to it, I can keyframe this, and we can come up with some very, very interesting sort of animations. But the deformer, the squash deformer, isn't the right deformer for us for that reason and for the counter animating reason. So we're going to re-rig this guy using a slightly different philosophy and coming up with, I hope, a little bit better a rig, right? So let me take this guy. I'm going to safely move him out of the way. I say safe because when we built the rig, we remember to freeze our transforms and delete history, right? Freezing our transforms means we can zero out the rig at any point, and it comes right back to world 000, right? So we built this rig cleverly so we can zero it out, right? So I'm going to come in here. I'm going to create a cylinder, and we'll make this relatively large, right? I'm going to hit F to frame up on it. Let's scale this up. Now, we want this at world 0. Let me scale this up. So what am I going to do? Well, the first thing I'm going to do is I'm going to move the pivot to the bottom of the cylinder so that when I scale it, it's not just going to go like through the ground, right? It'll actually start from the ground and scale upwards, right? So I'll move the pivot, and then I'll use that pivot to snap this guy to the world, right? So if you guys remember, I'm going to switch to my move tool by hitting the insert key. The insert key changes the gizmo so it looks like this, right? And I'm going to move it down. Now I want it to be exactly on that vertex. Remember, the hotkeys for snapping are X, C, and V. X because it looks like a grid, C because it looks like a curve, and V for vertex or component or whatever. So I'm going to hold down the V key, and then notice the middle of the tool changes to a circle, and I'm going to middle mouse button drag it right to that vertex. It snaps to the vertex. I'm going to hit the insert key again to come out of that, and there we go. We've got our pivot point situated, so now I can just scale it upwards from the ground. But we're still through the grid, so I'm going to hit the W key to get my move tool, and I'm going to hold down X, this time to snap to the grid, and middle mouse button over the center of the world. I am now exactly placed at world 000, right? So, let's take a look at the side view of this guy, right? Oh, I must have clicked, did I click I clicked the bottom view, didn't I? Yeah, I did. Okay. So I've switched using the hotbox, holding spacebar, hitting the Maya in the middle and going to the right view, right? Now I'm zoomed in super close to my object, but I have it selected, right? I can tell in the outliner I've got it selected. So when I hit the F key, it's going to frame my object, right? So that's cool, right? It gets me a little bit more to where I need to be, right? So here's my object, right? It's sitting at world 000, right? Now, what I want to do is I want to have that geometry controlled by something, right? These are my puppeteering controls. I want my control to sort of bend it and twist it like a leg, right? So Maya has something that we generally use to control the geometry, to bend it to deform the geometry. Now remember, in our original ball, we had our controls, right, which we set up, our geometry, which we set up, and I created a skeleton group, right? And so we've got that joint sort of in the middle there, right? Well, we're going to expand on the skeleton, and I'll show you how, right? I'm going to pop in here, and I'm going to come over into my modeling menu set, go to rigging, and under rigging are all the tools that you need to build the puppeteering controls for your character, right? So what I'm going to do is I'm going to grab a skeleton, and I'm going to create joints. But I'm not going to create one joint. I'm going to create 1, 2, 3 joints. Now I'm going to hit enter to complete that operation. It'll take me out of the tool, and I've created my leg joints, right? So I'm going to pop back out to perspective view. And another really good reason to work at world 000, it makes it easier to work inside the orthographic views. The orthographic views meaning the top, front, side, etc. And this is the perspective view. Okay, so we're in here. Now, what we want to do is we want to take this guy and we want to move it. Now, there's a couple of interesting points that I'd like to sort of teach you guys that you might not see in tutorials and things like that. I'm going to come in here. I'm going to create a locator, right? A locator or a null is just, I'll bring it up here and scale it up and show you. It's just the crosshairs, right? So we'll come on to perspective view. That's what a locator is, right? And it has no volume. It has no renderable qualities, nothing. It's just a point in space. That is it. There's no other value to it other than the transforms, right? So I'm going to come back out to the right view. I'm going to take this guy. I'm going to duplicate it, move him down here, and duplicate it, move him down here, right? Now, if I take these, and you can see it here in my outliner, if I take these locators, right? If I take these 2 locators, the middle mouse button drag under that one locator, and I take locator 3, middle mouse button drag it under locator 2. I have created a hierarchy of locators, right? So now I can take this, switch to my rotate tool, rotate it, right? Go down to the next locator, rotate it, and I've got a bend in the leg, right? Let's take this and move it across. Now, it's a parent-child hierarchy, so the children can move wherever they want, but wherever the parent goes, the children have to go, right? So that's basically it. So we've gone over hierarchies. Now, let me move this guy up and then down, right? In a similar pose. The joint is basically a hierarchy of locators. That's all it is. In fact, if you dig underneath the surface, it really is just a locator. They've just added a fancy graphic to make it look like a bone, right? So this is kind of an important distinction, or an important detail rather, because these points are what's going to control our geometry, right? Not this leg, right? This confused me for a long time when I first took 3D. This leg doesn't exist. This leg doesn't control anything. It's the point at the end, right? These legs are just drawn for us. So visually, we can see how the locators are connected together and it looks like a skeleton, right? But they don't exist, right? We are just dealing with 3 points in space in a hierarchy, right? So let me take this and let me zero out the joint. And I'll talk a little bit about sort of joint behavior. I see a couple of questions being typed. I'm going to come in here and grab that locator, and I'm going to delete it. Now, one quick little tip. When I grab that locator, the other two will highlight, and you think that you've grabbed it, and you'll hit delete, and oh, there it goes. That defeated what I was trying to say. But notice in the outliner, when I grab that root locator, the other two aren't highlighted. This will become important later on, right? So if I right-click, right, and select hierarchy, boom, look, it grabs all of them. So if you want to grab everything in a hierarchy, you have to select the root and then right-click, select hierarchy, and it grabs everything, right? Don't worry about knowing that. We'll run into it so many times, it'll become second nature after a while. Right? Trying to follow on Maya, but I'm so used to Cinema 4D that I have no idea where anything is. Yes. Yes. Yeah. Welcome to the world of jumping into a new piece of software. It's taken me 2 years, on and off 2 years, but I'm now comfortable inside of Houdini. Well, sort of. So, yeah. I feel your pain, man. It's just kind of like you have to struggle through and hunt and peck everything. I'm actually in the same boat with Blender. I'm like in Blender going, where was that again? Because I'm in Maya and I can find everything really, really fast, like super fast. So when I'm in Blender, I'm forced to slow down like crazy. It's like going from a Ferrari to walking. It's like so frustrating. Yes, you will countlessly run into many, many, many times wanting to go back to your original 3D package that you learned on. I encourage you to resist that temptation because you will be going through that more than just with me. When you get in Studio and you find out that Studio uses XSI or 3D Studio Max, not only will you have to go through this, but you will only be given a week to do it, right? Now, here's the good news, and I discovered this by accident. The first transition from the first piece of 3D software you use, the first transition to another piece is incredibly hard. The second 3D application you translate to is like exponentially easier. And then after that, picking up a new piece of software is easy because you understand how that software thinks. Because all 3D packages operate along the same 3D mathematical principles, right? Other than left-hand or right-hand coordinate system. But that's a whole other thing. But it's basically, honestly, all 3D packages speak the same language. They operate the same way. It's just a matter of figuring out the UI. Yes, it is only a matter of UI. I don't think I've ever run into a feature set that didn't exist in another 3D package or didn't eventually show up in another 3D package, right? So I'll give you a case in point, right? So Maya can do Monte Carlo brute force rendering, right? Nobody else can do that. Oh yeah, Blender can. Holy crap, right? So it's that sort of thing. Anytime you think there's a feature only one 3D package can do, you can bet the other 3D packages can do it, or they have plugins that are available that will allow you to do it, or there's something coming out in a point release that will allow you to do it. What's your method for learning packages and remembering it all, please, Al? Oh, here's what I do. Okay, so I remember the tutorials that I go through, like in Maya or 3D Studio Max, and I try to replicate the exact same thing in another package. Right? Does that make sense? So if you struggle to learn this bouncing ball and you get it and you know how to rig it and animate it inside of Maya, replicate the exact same thing, no deviance, in another 3D package. And that's how you start to figure it out. For getting comfortable with navigating, I always do an environment prop, right? Because an environment prop is just geometry, isn't it? It's just points, edges, faces, right? So if I build a building inside of Maya and I want to get comfortable with a new piece of software, I'll build the same building inside of Houdini, and then it's just modeling, right? Modeling is like the easiest, architectural modeling rather, and prop modeling is the easiest entry point, I think, into a new 3D package. Right? So back to this. So now we've got a piece of geometry. Now, in our bouncing ball, we were deforming that geometry with a deformer, a squash deformer. And what it's basically doing, what the squash deformer is doing, is it's basically moving all these vertices based on a force field calculation, right? But what we want to do is we want to take all the vertices in our tube leg and we want it to be moved by the joint chain. I'm just going to come back to this a little bit. Right? So notice what happens inside of Maya. I'm going to go to object mode. Notice what happens inside of Maya when I go to grab that geometry, right? Right away, it defaults to picking your skeleton rig. This is done deliberately because Autodesk assumes that by the time you're rigging the character, right, you're ready to build your animation controls, you're done with modeling, right? So there's the joint selection priority. Maya will always select joints first, no matter what. You can turn it off, but that's okay. We'll deal with that later. The other thing I want you to notice is the orientation of the joints. Here's where your brain will start to explode if it hasn't already. Right? This is kind of important, right? So notice that when I pick the root of the joint, it's completely zeroed out. 0 rotations, 1 on the scales, right? We used to have to manually do this, but now they do it automatically. This is how important it was. Remember I told you, stay away from scaling. It's a multiplier, right? If you have to scale anything, make sure it's the last thing you do on anything, right? Because it has unexpected results. Now we've got 2 sort of values in the translates. Well, what that means is we have to position that joint up on the y-axis, down the z-axis, right? So it has to have those values. When we move down the joint chain, check it. When we move down the joint chain, check it out. Zeros in everything, 1s in scales, and just a value in translate x. Same down here, right? A value in translate x, right? So what is that? Well, that means that this joint, if I were to switch that from global coordinates to local, right? And we do that by holding the W and then hold down the left mouse button. W for move, right? And hold it, keeping it pressed. Click on the left mouse button, go to object, right? Now we can see the orientation of that joint. And see the x-axis? It's pointing down the joint, right? So if we come up here, the x-axis pointing down the joint. This is really important. I'm going to pop back out in the perspective view, and I'll show you why this is important. Right. So with that x-axis pointed down the joint, animators are only ever rotating the z-axis when they're working on their animation rotations, right? In the preferred angle. Well, we'll talk about the other axes later. There's a reason why these conventions are in place. And they're in place for 2 reasons. Number 1, if programmatically you want to animate 2 legs at the same time, or mirror animation off from one side of the skeleton to the other, you want to make sure the joint chains are following the same kind of setup rules. Isn't it important because it shows the relationship between the joints? Yes, I will get to that. But the first order of business is making sure that you can cut and paste animations from multiple skeletons to other skeletons. Now, if you had one skeleton that had the rotation axes one way and you cut and paste that animation onto another set of joints with the rotations pointing the opposite direction, you're going to get like crazy unexpected results. But if everybody's using the same joint orientations, then people get kind of familiar with it. As well, if an animator opens up your rig, has never seen it before, we can jump right in and start animating. Because the animator will know that the X will be pointing down the joint and positive Z-axis will be the preferred angle of rotation, right? So there's a reason why those rotations are set up. Also, they're zeroed out for the exact same reason we zero out our geometry. Let's say we go like this and the director goes, no, you know what? I want that dude standing, right? And if you had crazy values on there, it'd be sort of a nightmare, but we don't. We just have to go in and zero out our joints and then we're good, right? You know, even if we do like something with crazy, like maybe it's winding up for a big roundhouse kick of some kind, right? Director says, no, I want the dude standing, right? So you can just pop in here. I've grabbed the top rotation, shift select the bottom rotation, just type in 0 once, hit enter. It zeroes out all those channels and we're good, right? Same here. I'm just going to grab those guys. I'm going to zero it out. Boom. Back to the beginning. Zeroing out your joints, zeroing out your geometry. It's a massively important part of your daily workflow, right? Okay, So once the rig is set, you can animate anything you want. Yes, and yes, right? Depending on the rigger, right? Some of you may find rigging enjoyable, right? But a rigger worth their salt will be able to develop a rig that you can animate almost anything, right? And the relationship between the joints, yes, right? So why have just the x-axis, right? Because if I wanted to scale this joint, right, I could do it like this, scale the joint. But remember, I said don't scale anything. It's a multiplier. It does weird and stupid stuff, right? So all riggers kind of know that. So they said, look, the riggers, actually Autodesk and, I don't know, it's not Autodesk. Sort of like an unwritten rule from all riggers all over the planet. Let's just put translations. Let's just use one translate channel to be able to scale the joint. So check this out. No scaling. I'm just grabbing translate and I'm moving it closer. I grab this one and translate, move it closer. And I've effectively scaled the joint, but not really. I'm changing the translations, right? And because it's directly in line with the x-axis, it's just sliding along the x-axis, right? So it looks like you're scaling the joint, but you're not. You're translating it up and down in the x-axis. That's why the x-axis is pointing directly down the joint, right? How would one scale then? Say if you were to animate a cartoonish pain, which is throbbing foot, etc. We will get into that. So that technique is something called a blend shape, right? So a blend shape is basically, I can save this shape on the ball, save the round shape on the ball, and just say, take all the vertices on the round shape of the ball and move them into the positions of the stretched ball. So that's a blend shape, blending from one shape to another. Yeah, blend shapes. Blend shapes is how we do the throbbing foot. I will introduce blend shapes in just a second on this particular rig, right? I'm suddenly realizing I might not have enough time, guys. There's a lot to sort of cover. But let's see how far we get. Okay, so I'm going to zero out my squash. Zeroing out, perfect. It resets it, right? So how do we get this joint chain? We've built it perfectly. All the orientations are correct. But as we rotate it, it's not moving the geometry. Well, here's what we do, right? We're still inside the rigging menu, right? So we're all good. And we've got this menu item called skin. So what this does is it basically attaches vertices to a joint. So like a parent-child hierarchy. So whenever you move that joint, the vertices will go with it, right? So to give you an example, what I want to do is I want to grab these vertices and have it travel with that joint, right? Oops, go into object mode and have it travel with that joint, right? The top joint. So we can do that by skinning the geometry to our joints. So here's how this works, right? So I'm always getting the selection order wrong. Let's see. So I'm going to select the root joint, select hierarchy, then I believe it's shift select the geometry. So I've selected all the joints and said, look, all of these joints, I want to affect this geometry. Then I go to skin and I go bind skin, right? So it says, okay, now your geometry is bound to that skin. Check it out. So wherever that joint goes, those vertices will follow, right? So let's check out our bend, right? So I'm going to come in here and bend. Uh-oh. What happened there? Something's going on. That's not working, right? It's like, damn, no, that's not bending like a leg. What's going on? Right? Needs an edge loop and an elbow. Yeah. The part isn't linked at the knee. It is. Remember, I selected all the joints and the geometry and said link them. Let's look at the geometry, right? Remember I said that each joint moves vertices that it's associated with. Well, we don't have vertices there. think about this cylinder as if you were making it out of cardboard, right? If I made a cardboard leg like this out of a tube, right? But I didn't put bend lines here, how's it going to fold in that area? Vertex paint it. Well, you could. There, actually, funny you mentioned that. There are ways of never mind. it's a bit advanced, but you can vertex paint to solve certain issues. It needs more verts. Yes, it does. Watch this, guys, right? So now I want to sort of decouple this from the skin, right? So how do we do that? Well, we go Edit, Delete by Type, History. Boom. It'll remove that skinning, right? So that means when I move these joints, it's not going to affect the vertices, right? So that's cool. We're back where we started, right? Yeah, I just unbound it by deleting the history, right? You can, I think, yeah, there's a more professional way of doing it. They've got this unbind skin. That's just my force of habit. I always just delete the history on the object and away we go. So what I'm going to do is I'm going to come in here, shift right click, and go into my insert edge loop tool, and I'm going to put an edge loop round about where the knee is. You might want to flip over to your right view if you want to position it nicely, right? So there we go. We've got a set of vertices there, right? So when I right click and go to vertex, wow, we got a ring of vertices. Now that knee joint knows what to grab onto and move, right? Now, before we go any further, let me go to the attribute editor, right? Because we've got the cylinder and we've got the poly split ring, right? Now, every time that leg bends, Maya will go, okay, I got to figure out the shape node, I got to figure out how it bends, and I got to figure out how it's split and do a new split ring. Okay, frame 2, the knee's moving. Okay, I got to figure out how it moves, figure out the vertices being controlled, and I got to do the split ring again, right? And it's calculating it every single time. The next frame, same thing. It calculates all that plus the split ring. It's like an additional piece of work that Maya doesn't have to do. When you have a whole bunch of operations, Maya's figuring out every single one of these file tabs for every sort of processor cycle or every frame. So we don't want that. We're done. We split it. That's cool. We're done. We don't need Maya to think about how to split it over and over and over and over and over again. So let's go back up, edit, delete by type, history. Boom, it's gone. So we're saying, look, we've cut it up. You don't have to think about it anymore. Just think about the geometry, the shape of the geometry, and the shader group attached to it, right? So let's come in here. We'll grab all 3 joints. This time I'm just going to, well, actually I'll do this properly. So I'm going to come up, grab the root joint, right click, select hierarchy. It grabs, oops, grab that. Oh, where did my joint selection priority go? Oh, okay. Well, you know what? I'm just going to grab the hierarchy in here, shift select this guy, and we're going to go skin and bind skin, right? At one joint. Why is it not? Let's back this up a little bit. I'm going to undo this back because, let's see. Oh. Still in my split ring tool. Okay. There we go. All right. So I'm going to come back in here, go to my right view. Go to my edge loop tool, shift right click, insert edge loop, pop one in there. Right click, go to object mode, and edit, delete by type, history, blow that away. There we go. Go back out in the perspective view. Okay, so I'm going to grab that root joint, right click, select hierarchy. Watch what happens in the outliner. Picks all of those joints for me. Now I'm going to shift select the geometry, and I'm going to go skin, bind skin. Boom. So let's check this out. So we got this, and it's moving this way. We got the next one down the line, and there we go. We've got our leg bent, right? Okay, so give me 2 seconds. I'll be right back. Real quick comfort break. Hey, buddy. Okay, cheers for that. I'm back. Okay. Okay, so let's I'm gonna back this up again and talk about modeling technique now, right? So actually, let's bend this up again real quick, and then down here real quick, right? There's still problems with that, right? Doesn't look like a knee. It's not holding on to its volume. This is where modeling technique comes in, right? So as you're modeling, you have to think about the character's deformation as you're modeling. And I'll show you a sort of a brief example of this. And it emphasizes the importance of topology. So I'm going to come in here. I'm actually going to go to skin and unbind the skin, right? Because I think maybe I can't get away with deleting the history on geometry anymore, because that looked like it led to errors. Okay, so I'm going to come back to the right view. And this time I'm going to shift select, and I'm going to use the multi-cut tool. I think this one will, nope, not that one. Let's come out of there. And where is that? It is the, did they get rid of the slice tool? I think maybe they did. Let's just insert edge loop tool again. So I'm going to bring that guy in there and that guy in there. Now, I'm starting to think about the topology, right? So I'm going to right click here. I'm going to grab these vertices. How do I get this geometry to maintain the volume and the shape of the knee? Well, first of all, it's like, again, like making this out of cardboard. The more bend creases you put in the cardboard, the more comfortably it'll bend when you try to fold it, right? So here, what I'm going to do is I'm going to rotate these guys. Move it up, right? Maybe scale it out a bit. And then these guys as well. Rotate them down, move them down. Scale them out a bit. And these guys, maybe move it forward just a touch. Scale it out, move it forward just a touch. So it looks a little bit more knee-like, right? So I've just made an adjustment in the topology for its deformation or its deforming, right? So I'm going to come in here. Now I've got like loads of split rings, right? So it's going to go and it's going to think about the shape and the split ring and another split ring and then go to the next frame, think about the shape and another split ring and another split ring. We can't have Maya doing that. So we got to edit, delete by type, history, right? So that's all gone. Now we just have the transform node, shape node, and the shader, right? I'm going to grab this, right click, select the hierarchy. That grabs all the joints. I'm going to shift select the geometry, and I'm going to go skin, bind skin, right? So now, let's go out to perspective view so we can see this a bit better. Now when I come over here, bend this guy, grab this one, bend that guy. It's got a little bit more volume. See that? It's keeping the volume. It's not like pinching there. Solved simply by clever modeling, right? So understanding how your topology will eventually look when your character is rigged is part of the job, right? Okay. You know what? Because I'm here, we're at 159. Yeah, 2 o'clock. Yeah, I think I will. Yeah, I'll introduce you to. No, I'll introduce you to blend shapes when we move on to the bouncing ball. Okay, so what we've covered there is a very, very brief, lightning fast introduction to joints and what they are and how they need to be oriented to be able to move, to create the proper puppeteering skeleton or character armature for your geometry. Then we built some simple geometry, and I showed you how the edge loops or the topology or how many fold lines in that geometry will help when you're moving the character around with your armature or your skeleton, right? What about these loops? Those are the control objects, right? So here's what I'll do, right? So if I were to come in here and say, okay, well, there's the geometry, there's the skeleton, but there's no real easy way to just grab the skeleton. It's like, oh, oops, I want to grab that root joint. Oh, oops, there we go, I got the root joint, right? So that's really frustrating and annoying. So we have our skeleton, we have our geometry. Now we build our puppeteering controls for this guy, right? So I'm just going to go real quick. I'm going to create a NURBS primitive circle, right? And then we'll scale that guy up and we'll move him up here, right? So this is the control that will move the joint, that will move the geometry, right? So I'll take this and I'll shift select or control select the top joint, and then I'll constrain it with a parent constraint. And that means when I move this guy, it'll take that with it everywhere it goes, right? So that's what those loops are. Those loops are the NURBS controls that allow you to move the joints that move the geometry, right? Basically, the puppeteering controls that are easy to see in the viewport, easy to grab, and easy to move around. This is what will eventually get our keyframes, right? So if I were to animate this guy, I'd set a key on here and then move to another frame and then move him over here, set a key on there. Away to go, right? So a little addendum for the games guys though. No game engine SDK like Unreal or Unity on the planet recognizes controllers or puppet controls, right? So what do we do there? Well, after the animator is finished, what an exporter does inside of Maya or any other package is it'll go through and it'll select every single joint and it'll save keyframes on all those joints. So what ends up inside the game engine, and generally the controller will then be deleted, right? And what ends up inside the game engine are just the joints with keyframes on them and just the geometry for the character. That's what ends up inside a game engine, right? And that's when you're done all your animating, everything's been approved, and it's all locked in, and then you do your final export of the animation, right? So that's that. Let's grab the cylinder and grab these joints, and we'll just kill them. How did this guy end up there? Okay. And we're going to take our character, and we're going to grab that control. We're going to switch to our channel box. So it's easy to just select these and zero that out. Boom, our character's back in the bottom. We're also going to grab the squash controller, zero that out. Boom, our character is there, right? Oh, any questions about that so far? Are you guys still with me, or are you in brain fried territory? So far, so good. Yeah, the squash controller is appearing on the object, yeah. Yeah, that's the best thing to do is just try it out and kind of get used to it. It is a lot to learn, but if you compartmentalize what I'm talking about here, really it's this idea of remembering that the geometry and the skeleton and the controls have to remain separate, right? The geometry is being controlled by the skeleton is being controlled by the controls, and we are manipulating the controls, right? So that's what we're setting up, and that's what we do when we're creating, what manner of sorcery is this? But that's what we're doing when we're creating a character rig, right? I mean, I used to go really in deep into how to reset the orientations on joints, but thankfully I don't have to do that anymore. A lot of that happens behind the scenes inside of Maya. I'll tell you what, why don't we take a 5-minute break? I'm going to refill my coffee because it's 2:05. And that way you can absorb a little bit. Because we're going to take everything that I taught you in the first hour and we're going to apply it to our little guy here. Including just a little bit of modeling as well. Yeah, manual joint orientation is a huge pain. Thankfully, we don't have to do it anymore. Right? So, that's cool. I've had to do that many, many times in production to reorient joints. But it's all good. Maya automates all that stuff now. Okay, I'm going to take 5. I'll be right back. And then we'll dive into how we can improve our ball here. All right, I'll be right back, guys. What's that? I'll be right up. Hang on a minute. There's super noodles here for you. You want some? Okay. Hey Connor, do you mind moving down the middle of this? All right. So, okay, guys, I'm back. Oh yeah, have you tried pressing S to set a key? Yeah. Okay, well, we'll take a look at the flour sack rig in just a second, and I'll talk a little bit about keys. Back with biscuits, awesome. Okay, so I know this is a lot to absorb in the beginning, but hopefully it'll start to get a little bit easier as we get along. Okay, so now what I want to do is I want to create a brand new rig, and I want to sort of remove the deformer because I don't think it's necessarily working for us at this moment, right? So what I am going to do is, I believe this is just, so we got a parent constraint on that joint, and it's just, it should just be, did I skin this? Let me see. Let's see if we can unbind this. I don't think I would have skinned it. I think. Oh, there we go. It's parent constraint. Right. Yeah. Okay. So last class, all I did was parent constrain the geometry to the joint. But now we're going to do the skinning process instead, right? So where the vertices of this ball will follow the joints that we create for it. So to do this, I'm actually going to get rid of our squash handle, right? Now I'm going to save my character. Now when I save the character, I'm going to go to save scene. I'm going to open up the option box. And the reason why is I want to make sure incremental save is turned on, just in case I want to go back to the squash handled version of my rig. At least I've got a version of it that I've saved. Now, why don't I save this under a different name? Because if I do, it won't appear in my layout, because my layout is referencing this file, this character1 ball1 file. So I don't want to change that name. So I want to make sure it's just incrementally saving, so I got a backup copy later. Okay, so let's go back and rig our ball a little bit differently, right? So to do this, I'm going to go to, really I could take any view, I suppose. Let's go to, yeah, the right view is fine. And so we're facing forward this way. Now, I'm sort of making this up on the fly, guys. I've never done this before, but in theory, it should work, right? So I'm trying to think, which way do I want this character to bend? So I'm going to come in here, I'm going to create joints, right? And I'm going to X snap my first joint to the bottom of the grid. And then, I don't know, I'll find somewhere over here to do that. And then I'll X snap it to the top of the grid here. And then hit enter. So I've got my joint chain, right? Now it's incredibly big, right? So what do? We don't want to scale the joints, right? Remember, because we don't want to scale anything. What we can do is we can turn the display of our joint sizes down, right? So we can do that in display. Where are you now? Display. Oh, I think they moved it, didn't they? Is it under skeleton? No, I'm sure it's under display, object display. Where are you? Joint size. Normal size, face normals. Oh, here we go. Animation. There we go. Display, animation, joint size. Right? So inside here, once we do that, we'll get this slider, and we can just crank that slider down. So we get a nice joint chain, right? Whatever you're comfortable with. Hey, that's a good aside, guys. By the way, when you guys mentioning James, you know, for the learning in the digital era, I'm supposed to help support you guys. So if you guys are a little bit lost or that kind of thing, we can set up a separate session where I do 1 hour of learning in the digital era. So let me know if that will be useful for you guys. You know me though, guys. You must know me well enough by now to know that if there is a pointless course that you guys are taking, you want me to teach it to you, because I will find a way to make it industry relevant. Right? Like, case in point, I'm teaching the level 7's research, what is it? Research methods and communication in level 7. Right? You know what I'm teaching them in research methods and communication? How to design screenplays for an entire season of a television series, and how to do a pitch pack and all that kind of stuff for it. right? So industry relevant and a little bit more fun to do, right? So yeah, with learning in the digital era, I'll have a look at it. And if you want like an extra hour of tuition from me, I will find a way of taking something industry relevant and shoehorning it into the teaching and learning outcomes of learning in the digital era, right? So just let me know. Okay, so here's what I want. I want to be able to like bend this guy. Maybe the angle's a bit too extreme, right? I want to be able to squash and stretch him, but have him kind of bow, right? And then, you know, be able to take the translate X and have him stretch up and do all kinds of stuff, right? So I want to try and figure that out. You know, I'm going to back up on the joint creation because I think I want to create the joint set differently. I'm going to actually go back to my create joints. Now, this isn't going to be perfect either, but I'm using it to just teach you guys a few concepts, right? So I'm going to come up here, and that's good, right? Here's a question I oftentimes get. Does the joint chain have to be inside the geometry? No, it does not. It's just visually and workflow easier if you draw the joint chain inside. But I've had many, many issues where I've had to solve it by creating a floating joint chain outside the geometry. It doesn't get rendered at the end of the day, so it's fine. But it's just easier to wrap your head around if you put your joint chain inside the geometry, right? It's just easier. Okay, so I've got that joint chain. I don't know what you know what? I'm just going to leave the default naming because a ball doesn't really have joints in it, right? So I'm going to take this, and hit enter to come out of that tool, right? So I'm going to grab all of these joints, and I'm going to middle mouse button drag it to where it belongs inside my skeleton group, right? No, I just want to grab the root of the joint and pop it into my skeleton joints. There we go, right? So now my skeletons are where my skeleton is where it needs to be, right? So I'm just going to go straight forward and, well, actually, I'll call this one the root. There we go, ball one. There's my joint. And this is called the end effector, right? It's an industry sort of term, right? The last joint on a joint chain is called an end effector. And the end effector, you generally don't skin anything to it, but we'll break the rules here in this case, right? Just so that you guys get the relationship between vertices and joints, right? So we've got those. Now, a few things I want to do. I want to start rigging this so it can work in both a game context and a animation context. So I'm going to create something down here called a trajectory joint, or trajectory bone, right? So I'm going to hit X. I'm in my joint creation tool. I'm going to tap on the grid center there. Oh, it's not going to let me do it. Okay, I'll do it slightly off, and then we'll move it into place. So I'm going to create one there. Oh, cool. It grabbed my parent root joint. That's fine. That works for me. So I'm going to grab this other joint, and I'm going to go back to world space, and I'm going to pull it out this way, right? No, sorry. Let me back up. That's why I need to create a separate root joint. So I'm going to come back in here again. I'm going to go to my skeleton, create joints. I'm going to X snap it to here, and then X snap it to here, right? And I'll explain what I'm doing with the trajectory joint in just a second. Then I'm just going to sort of X snap it, X middle mouse button snap it to the center there. But I want to keep that joint hierarchy separate from the other joint hierarchy, right? And this I'm going to call my trajectory. Trajectory joint 1, and then trajectory joint 2, right? So you guys want to hazard a guess as to why I'm creating a trajectory joint and why I'm also saying this is more specifically for games? If you don't know, that's cool. We don't really need it in this case, but I thought I'd introduce you guys to it. So if I were to create, say, just running on the spot, right? Or walking on the spot, right? How do we get the character to move around and be controlled by the controller? Well, there's where the trajectory joint comes in. The trajectory joint is what's mapped to your controller, right? And wherever you move in the world, you're actually moving the trajectory joint, and it's bringing your whole character hierarchy wherever with it, right? So that's the trajectory joint. I'm going to leave that down there. Well, actually, I'm going to kill it because I don't think we need it for this particular exercise. But just to give you an idea, right? So that trajectory joint maps all the controller input data in terms of where the character translates in the world. I mean, it's more complicated than that, but it's a good sort of simple concept to wrap your head around when trying to understand the trajectory joint, right? Now, I'm going to take this controller, which should now no longer be constrained to anything, right? And instead of grabbing it around the middle, which doesn't make a whole hell of a lot of sense, I'm actually going to move this, and I'm going to X snap it down to world 000. So I know where that character is along the ground, right? Or the extent of the ground, right? So there we go. We've got that. Now all we want to do is we want to grab all of our joints, right? And shift select the geometry, and let's go into skin. But before I hit bind skin, I'm going to go over to the option box, right? So what the option box allows you to do is set a few things, right? So I'm going to say, let's bind to the joint hierarchy. The one, I'll talk about all of this later when we get into character rigging, but really we just want to take a look at the drop-off rate, right? So remember I showed you the soft selection brush? Here, actually, I will do it this way because it's always easier to take a look at it visually, right? So if we take a look at soft selection, right, you can see that there's a gentle fall off, right? So when I grab some vertices, it strongly influences the one in the center, but then as the color fades off, there's less of an influence on the other joints, right? That's basically what we're looking at when we come in here and we go to skin, bind skin, and we're looking at the drop-off rate, right? So we know that that joint is going to control a bunch of vertices and will drop off by, 4 units down the outside skin of the sphere, right? But we're not going to change anything. I just wanted to show you the option box for now. So let's see. Yep, it's doing its thing. And let's see. Do we have deformation? We do, a little bit. And we can also grab the translate X and move them up and down. Right? It's not perfect, but it's not perfect for a reason. I just want to show you some of the kind of the key concepts behind rigging and that kind of a thing, right? So perhaps a joint chain and a straight line would have been better. Yeah, probably actually, because we could still bend it and kind of turn it and look in various different directions. But that's okay. That's good enough for now, right? So now wherever that joint goes, it's going to bring the ball with it, right? But we want to use the controller. So we need to reconnect up the controller, right? So now I've got my geometry separate, I've got my skeleton joints separate, and I've got my controller separate. So I'm going to take my controller and I'm going to... No, I've deleted the deformer now because I'm using purely joints to deform the object. Yeah, okay. We could probably build that deformer back in. There's nothing that says we can't, right? Okay, so I've got my controller and I'm going to control select the root of that joint, right? And I'm going to go to constrain. Now constrain means to attach two objects together and share translations if you're in point, rotations if you're orient, or scales, right? Or all three of them. Translate, rotate, well, translate and rotate because of the parent relationship. So I'm going to choose the constrained parent constraint, right? So that means when I grab this, right, it will mimic the parent-child hierarchy. In fact, I could grab the root and move the root on its own, right? But the objects don't have to be in a hierarchy, right? They can be located in separate areas of how you organize your character, right? So that way the animators, all they have to do, again, is to grab that controller and move it around, and they've got their ball that they can animate, right? So far, so good? Now, I showed you that to kind of animate the scaling, we grab the translate X and we move that X up and down. It's not perfect again because I should have picked a different angle for the joint chain. But remember, we don't want the animator to go in and grab those joints and moving it around, right? So what we want to do is we want one controller for a ball, and then everything accessible down here, right? We've got that squash channel. We don't need it anymore. So we can right click and I believe I can delete it. Oh, no, I think I have to go into the channel controls to get that. That's okay. But we can also add channels and attach the X translate to it. So actually, I'm going to come over here to my channel control. I'm going to take that squash channel inside the channel control, and I'm going to move it over, right, with this move. I'm going to move it from where it's keyable and accessible here to just my non-keyable hidden list. So it's gone, right? It's gone. We don't have the squash deformer anymore. We don't need it. So that was in channel control. That was under edit, channel control. Now, again, I can create a blank channel here for effector ball 1 and just connect up the X translations and have that all here, just like I did the squash controller. But I'll touch that later. We'll add that later, right? When we start building in custom attributes and things like that. Because there's a few other things that I want to talk about that are important in terms of our character rig, right? Okay, so that's it so far. Now we've got the character set up more like you would an actual character, right? Well, we've got a joint chain system, and we've got a control, and it's all set up with a skin. Okay, now what I want to do, I want to build a tail. Right? So let's see if we can build a tail for this guy. Okay? So I'm going to go back in the geometry, right? I'll probably have it as a separate piece of geometry. Now, you can make that call. You can either make that geometry part of the ball, or you can make it a separate piece. We'll make it a separate piece because it'll be easier to sort of wrap your heads around. So let's go through some fairly basic modeling techniques, right? I'm going to come back over to the right view, right? I'm going to create a cube. I'm going to move that cube over here, right? I just created that cube by clicking the shelf icon. Now, we're here in the channel box, but I want to get to the attribute editor because I'm modeling now, right? Remember, the channel box is better for animating. So let's go back down here to the attribute editor. And, you know, the first thing I want to do is scale this guy up, right? And actually, I thought it would come in with more subdivisions. It hasn't. That's good. That's cool. So the subdivisions on this are fairly straightforward. In fact, I could probably use the subdivision sliders initially to get the values I want, right? So what I want to do is I'm going to come in and let's take that, oops, the width, the height that way. Nope. And we'll do the, oh, it's hard to control. There we go. Do the width that way. And then we'll do the depth this way, right? And then we'll just move it into place, right? Now I'm going to think about what subdivisions I want through the depth. We're not going to make anything super complicated. Yeah, maybe, I don't know. Something like that. There you go. And I'm going to go back to the right view so we can raise this guy up, right? He doesn't necessarily have to, the tail doesn't necessarily have to sit on the ground. And I'm going to name this guy skeletal mesh, tail 1. Call it tail 1 in case we want to make the 9-tail fox. Okay. So now I'm just in the side view. I'm just going to grab the vertices. I'm going to hit B to come out the soft selection tool. Hit R to scale this guy down, right? And I'm just going to leave that one maybe. And then just sort of, you know, model something relatively tail-like. Something like that. I don't know. I'll move this guy up. Yeah, it's a pretty amazing tail, hey? Oh, I've never seen a tail like this before. Woo! I don't know. Something like that. Right? I'm going to pop out in perspective view. And okay, so that's cool. Now let's say, okay, we want to round it out a bit. It's too kind of rectilinear. So we want to add subdivisions maybe through the width and the height. Watch what happens when I try to do it on this polycube node that appears right when I create the cube, right? So if I say, okay, let's, oh, crikey, that's not really working, right? That's an important point because the nodes that you add or the tabs that you add in the attribute editor work on a dependency. So certain values will affect certain others, right? So you can't necessarily just go back and adjust sliders. And if you run into this issue while you're modeling, how do you get out of it? Well, here's how. Edit, delete by type, history, modify, freeze transformations. Are you getting it? Are you getting it? That repetition, right? So it blows everything away, right? Now what I want to do is I want to come in here in the edge, right? And I'm going to shift, right click, insert edge loop tool. I'll put one here, right? It'll go all the way through. Now, whilst that edge loop is still selected, I am going to scale it out. There we go, right? Cool. I'm going to select this edge. Now, I want to do the same operation again. Maya comes with a G hotkey that lets you repeat the last thing you did, right? G, boom. Oh, it doesn't do it. Oh, come on. Oh, it got me into the tool, but it didn't do it for me. There we go. That's fine. So I'm in the tool. I got that, and I'm going to scale this up a little bit. And there, the tail is a bit rounder, right? So I'm not going to go to town on this because I just want to create a fairly simple one, right? Now I want to get rid of all those operations again on that tail, right? So we grab that geometry, edit, delete by type, history, modify, freeze transformations. Now there's one exception to this rule. The minute you skin geometry to a joint, you can no longer delete history, right? Because Maya's geometry needs to know the history of that it's attached to a bunch of joints. This is why in a typical pipeline, you finish all your character modeling before the final rig is sort of put in place. I mean, I say that, but there's usually a bit of back and forth, right? And there are ways of saving your skinning data and reapplying it and all that kind of stuff. But generally, for you guys as students, what you want to do is remember, finish all your modeling first, delete all your history off that model, then build your skeleton, then skin to that skeleton, right? And it's safer if you get used to that sort of thought process. So now I'm going to take this geometry and I'm going to put it in my geometry group. Now I can do a few things with this. I can combine it, right? I'll show you how that works, right? So I can actually come in here. I got two pieces of geometry. Let's say I just want one, right? So first I'm going to come over here. Yeah, let's do this. I do want to reskin this whole thing anyway. So let's come in here and we'll go to skin, unbind skin, right? So that's unbound, but my constraints are still working. So that's cool, right? So I've unskinned the geometry. So I can show you this. I can grab the ball and then the tail. And for this, I'm going to come up here and I'm going to jump back to my modeling menu, which you can also find in your hotbox here. And I'm going to go into mesh combine. Watch what happens, right? So I've just combined it so that it's one piece of geometry, right? So it's like one character, right? I should have crashed the tail through the geometry. Actually, let's do that first. Let's do this properly. So I'm going to take this guy, I'm going to crash the geometry through, right? So that when I come in here and turn off X-ray, right? The tail looks like it's actually coming out of the body of the sphere, right? And then I'm going to edit, delete by type history, modify, freeze transformations. Modify, freeze transformations, right? Now I'm going to grab these two pieces of geometry. Remember to be in the modeling menu, go over to mesh, and then combine. Boom, combines the two, right? Now notice what Maya does when I do that, right? It pops it out of the hierarchy, says, look, you got a new piece of geometry, but I will remember everything about those two pieces in case you change your mind. So I got these group nodes, and all they're doing is they're saying, look, I remember there used to be a ball here. There used to be a tail here. There were some transforms on them, right? And they're just ghosts. And we want to get rid of those too. Let's say we've done it. It's just like, look, man, you don't have to remember all that. I'm done. I'm done. Now edit, again, delete by type, history, boom, they're all gone, right? All gone. And weirdly, it took my mesh group node with it. Why did it do that? That's really bizarre. Edit, delete by type, history. Oh, that's all right. We'll just make a new one. So I've made this new geometry node. I'm going to pop it inside my character hierarchy, right? So there it is. We got my skeleton, I got my controls, and we got my geometry, right? I'm going to turn back on the X-ray so I can see through my object, right? So that's it. We're done our character modeling. There's our geometry, all one piece of geometry, right? But we've just got a skeleton for the body of the character. You know what? This is annoying me. Let's go back and do it properly. I'm going to kill this joint chain. First, let's get rid of the parent constraint, right? You just do that by highlighting the constraint and deleting it. The control is good. That's fine. Let's grab this joint chain and let's delete it, right? So we're clean. We've got one control object and we've got our geometry. We're clean. We can start over again. I always like to take a second glance over to my attribute editor, make sure everything is zeroed out. My controller is not zeroed out. See that? So I'm going to come over here and modify freeze transformations. Oh yeah, that's right. We can't do it on a NURBS object. Yeah. Okay, that's cool. Okay, so let's go in and build our joint chain again. Now for the joint chain, I'm going to go back to the right view, right? And now you can see why I have X-ray mode on for the geometry, so I can see the joint chain that I'm creating. So let's come back into our joint chain. It's not here because I have to go into my rigging menu. Ah, there it is. So there's my skeleton, right? Click on skeleton, create joints. So I'm going to hold down X to snap to the grid, and I'm going to put something there where it has the option to bend, and I'm going to X snap it up here at the top as well. So that's a straight line joint chain. That's cool. I'm happy with that. I'll just call this root 1, and then I'll call this other one effector 1, something like that, real quick. And I'm just going to middle mouse button, drag this into my skeleton group node, so it's there. So there's my skeleton for the body of the sphere. Might as well constrain my control object now, right? So I got the root of the joint and the control select, or shift select, sorry, my controller, and I'm going to go to constrain, parent constraint, right? So now wherever this guy goes, oop, I went backwards. I'm going to grab control and then the root of the joint, constrain, and parent constraint. Aha, that's what we wanted, right? So now that's good. So now what I'm going to do is go back to my right view, right? And I'm going to go to my skeleton, create joints, right? And here, I'm just going to draw a straight, actually, I'm going to use the grid. I'll show you how I'm going to do this. So I'm going to X snap this to the grid so I can draw a relatively straight line, evenly spaced. Yeah, I'll go all the way to the end, right? And then I'm just going to lower this guy into position, right? So I know that that joint chain is like perfectly straight, evenly spaced, right? Now I've got translations on the root of the joint, but that's okay because each subsequent joint is zeroed out, so it's all proper, right? And I'm not going to bother naming this just because we know it's the tail joint. Actually, maybe I'll name at least the root of the joint, so we know what we're dealing with. And a middle mouse button, and I'm going to put this in my skeleton. Now I'd like to attach that to my. Just thinking if I should teach you guys broken hierarchy. Now we'll make it one hierarchy. So I want to attach this to that. Well, how do I do it, right? So let's pop this guy open, right? We've got our root joint. If I take the tail joint, middle mouse button, drag it onto the root joint, watch what happens, right? It's just parented to the root joint, but Maya draws in that extra bone for us, right? So then we can see that kind of relationship. Also, because it's connected now, it'll move wherever that controller goes, right? So that's cool. So we've got our joints set up, and it's parent constraint to that. Now what we want to do is we want to start building some control objects for our tail. And then we want to set up a control for the tail so that we can get it to wave. Tom is typing. You okay? You serious? Was it a mild shock or what happened? One of my students just got electrocuted. Oh, Jesus, that must have hurt. Oh. Yeah, I hope you're okay. Wow. That always terrifies me because in North America, we're 110, right? And you guys are 220, 230 over here. Right? It's like double. Which is kind of cool because I've noticed things like hair dryers and stoves and stuff heat up lightning fast. If you guys haven't been to Canada or the US, right? Get used to waiting for things to warm up. Kettles will probably take 3 times longer to boil water. I do like the electronics. I like the mains here in the UK a lot better. But I miss the small mains plugs in North America. Your mains plugs are honking huge. Okay, before I get distracted again by talking about mains leads and stuff. Okay, so I'm going to put some placeholder controllers in here for now, right? So let's come in and I'm going to create, again, it's just the NURBS primitive circle, just like I did before, right? And I'm going to scale it up and I'm going to rotate this guy around like 90 degrees, right? So I'm going to come over here. For the rotates on that controller, I'm going to set it to mathematically 90 degrees, right? And then let's go to perspective, sort of right view, and let's move this guy into place, right? Now, if I V-snap it, it'll snap to the center of that joint. I'm not sure if I want that. Let's do that for now. Whoa, that was a crazy sneeze. So I'm going to Control D this and move this guy down, and then hold down V, and then middle mouse button snap it to the center of that joint, and so on and so forth, right? And then V, middle mouse button snap, then V, middle mouse button snap. And we don't need one for the end effector, right? We don't need to name these guys, right? Okay, so I'm going to take my NURBS controls here and a middle mouse button drag it onto the first one so that they're all parented, right? So we can grab the one and we can move it around. We've got all of these guys, right? Whether or not I want a dependency, I don't want a dependency just yet. So we'll keep those kind of free floating, right? So how do we control this joint chain? So if we take a look at the joint chain here, right? And I was saying, okay, we got to go and like rotate and etc. to get the bend. And then we can come over here and then in our channel box, we can control the X translate. And this is where we're going to eventually get our squash and stretch, right? But if we come to the tail joint chain, oh my God, to animate the tail, we'd have to rotate this and then rotate it again and then rotate it again. Oh my God, it'd just be a nightmare rotating every single joint. Imagine if that tail was like 20 joints long, right? So there's got to be an easier way to do this, right? Well, there is. So what I'm going to do now is I'm going to put what's called an IK handle on this joint, right? So what the IK handle does, I will get into the theory behind a rotate plane solver, but really what it is a mathematical equation that allows you to manipulate many joints in a chain. It allows you to move one joint and have that move sort of translate down the other joints in a logical manner, right? We use IK handles for legs and arms as well. But in this case, I'm introducing you to the IK handle in just a joint chain. So with this, I'm going to turn on, do we want the single chain solver? I'm just going to pop over into my notes here because it's a long time since I've done a joint chain in this manner. Let's see. Am I in the right tool? Let's see. IK spline handle. That's why it did not look familiar. Okay, so in the... let me back up and explain what I'm doing. Okay, so in here, the IK handle is what I use generally to rig legs. The IK spline handle, what that does is it draws a spline curve through all of your joints so you can manipulate it like a curve, right? So we're going to do that. I'm going to pop open the option box and I'm going to set the number of spans to 2 and auto parenting is on, right? So with that set, I'm going to grab the root joint and go all the way to the end. And there we go. The tool is done, right? So there's our IK handle. Now, if I come in and let's turn off the geometry, right? Now, I showed you guys display layers for hiding geometry and showing geometry and all that kind of stuff, but you can also do that in here, in the viewport, right? So over here is the show menu. The show menu comes in very, very handy when you start working with complex objects, right? So in here, look, you just get a list of ticks of everything that Maya will show you in the viewport, right? So we can say, you know what? Turn off all the polygons. Boom. Gone, right? So the geometry is gone, but we are left with the joints and the controllers, right? Now, check out what that IK spline handle has done to the joint chain. In fact, I'll come over to show and I'll turn off my joints. Let's turn off the joints. So here's what we get, right? We get this spline, right? Now, if I were to right click on the spline and say show control vertices, right? You can see, let me Alt B the background so it gets a bit darker. You can see that I've got vertices. Well, control points. I think that's where they're control vertices for this spline curve, right? And we can take this and we can manipulate it. And look at that. So that looks more tail-like, right? It's a smoother curve, etc., etc. So what we want to do is we want to have our controllers control each of these sort of control verts, right? Now, there's an interesting intermediary step to getting this to work properly, because the control vertices on a curve, you can't attach anything to them. They don't really occupy physical space. It's just a calculation on that line. So what we have to do is create something called a cluster, right? So a cluster takes a point in space and says, look, it exists. You can attach things to it, right? So I can't attach anything to this right now. But if I select this and I go to deform and cluster, and I'm going to open up the option box real quick. And I'm going to turn on relative mode, right? So the cluster stays in a location relative to the control vert, right? So I'm going to apply this. And now you can see the letter C appear over it. Now it's got something that I can attach things to, right? So when I move it, you can see I move the curve as well. No different than actually grabbing the control vertex. It's just that the CV, the control vertex, I can't constrain anything on it, right? So that's why I'm doing this. So we're going to go over to the next control vertice. I'm going to right click and go to control vertices. And the next one's here. Yeah, I created too many curves. That's all right. Too many controllers. So I'm going to come over here and I'm going to deform cluster. Oh, let's make sure that that cluster is relative. Yep, cool. That one's like that. I'm going to right click, control vertices, go to the next one. I'm going to hit the G key to repeat the last action that Maya's done. And we have a one there. And I don't think I need one at the end. Yeah, I think I do. Actually, let's grab this one and then... Actually, I don't know if I can attach a cluster to the end. Let's try it. No, I can't, actually. Oops. Let's grab this line. Control vertex. I'm going to try one more time. No, it won't let me. Right? That's okay. Right? We've got enough here that it'll work for us. Right? So I'm going to come in here. I'm going to delete these other controllers. It looks like I won't need them. Right? And I'm going to just going to take another quick peek inside the attribute editor to make sure that relative is turned on. Now, there are two terms that nobody ever explained to me when I first started learning 3D. The terms relative versus absolute. You'll hear this a lot. You'll hear it in reference to rigging, in reference to creating directories, in reference to textures, right? So what does this mean? Absolute means that I have strict rules as to where something is. So the best example is if I store a texture in C:users, right? That's an absolute path. Wherever you go, it's going to be in C:users, right? Now, if I go C:users C colon backslash users backslash project backslash texture, and I say this is a relative texture, that means that Maya will go, am I in the right project folder? I am, so this must be the texture, right? So that texture stays relative to wherever the project is. And it doesn't need a drive letter. It doesn't need a directory path. Does that make sense? Relative means I understand where I am in relationship to this other object. Absolute means I know where I am because I know what room I am, what house I'm in, and what city street I'm on. So that's absolute, right? There's no question where that object lives. So object, absolute and relative, it's a concept that you'll see pop up quite a bit, right? I hope that metaphor made sense. I just sort of pulled that out of the top of my head. Okay. So let's get this guy kind of sorted out now. I'm just going to pop over. I got my clusters set up. That's all good. You guys following so far? Is all good? Yeah. So tail curves are there. So I'm going to control. So yeah. Okay. So I'm going to parent constraint each of these clusters to their respective controller, right? So I've got this cluster selected. I'm going to shift select the controller, right? Just like we did earlier. And we're just going to constrain and parent constrain it. Now I'm going to test to make sure I picked it in the right order. I don't think I did. I think I got to grab this guy and then shift select my cluster, right? And then constraint and then parent constraint. So when I grab this, this should go. Oh, I can see I don't need these guys in a parenting relationship. So I'm going to shift P to get it out, or you can just middle mouse button and kind of drag it out, pop it in the root, right? And it'll take it out of there. And then I'll grab this and I'll move these guys into the right place underneath everything, right? And then there we go. So this way I can move each of these controls independently, right? And it won't affect the other. I'll middle mouse button this guy and move him up here, right? And I can move this guy, but that guy's not affecting the cluster. So I'm going to grab the controller and then the cluster and then G to parent constraint that guy again. And now we got something that controls that curve. And then lastly, this guy and hit the G key and we're good. So if we come back here, we can see that we now have controllers that we can translate and animate that tail with, right? So that's kind of what we are after, right? I'm just gonna move on ahead and root to the root control. Yes, that's right. Okay. So we've got the main controller here, right? And that's moving around. We want that main controller to constrain the root joint to the root control. Let me see. Just going to double check here. Parent constraint each cluster root to the root control. Yeah, that's right. Yeah, okay. Okay, so what I need to do now is I need to make sure that these cluster groups follow with my main controller, right? Because they're not going to at this point. They're just going to float around, right? But I've got the cluster handles being controlled by these NURBS controls, right? So I can't really attach them comfortably to my root controller, right? So what I'm going to do is I'm going to take each cluster handle and I'm going to group them, right? So what the group does, I'll show you when I do this, is it packages up each cluster, right? I can still grab the controllers and move the clusters around, but the clusters are in a group node that I can now attach to the root controller. So your brains are going to blow up now, I think. So I'm going to take that group node and I'm going to control click that, or shift click rather, that root controller, and then I'm going to parent constraint these guys together, right? Let's see if I did that. No, is it the other way? I think it might be the other way. Grab the root controller and then that group, and then constrain, and then parent constrain it. Yeah, there we go. So that's kind of following along with that controller, which is sort of what I want. And that was that group, and then controller. No, it was controller, then group, then hit the G, and then controller, then group, hit the G. And let's see, we got that. Oh, something's not quite right now. So we point constraint the cluster to the tail controls. Oh, I see what I did wrong. There's the group constraint there, and constraint root joint to the root control. Let's give this a go. Let's see if this works. Each cluster group to the root control. Yeah. How come you're not working? Root joint. This guy to the root controller, right? And all right. So let's see if we've got the correct hierarchy. So we got these guys in here and tail joint onto the curve. Okay, so I'm going to take my tail controls and I'm going to, and the IK handle, and I'm going to middle mouse button and parent them to the ball control, right? So now we should have a little bit of activity there. And then I'm going to grab these guys and they're moving okay this way. Yeah, that should be all right. Okay. So the difficulty I had there was just in sort of figuring out how I was then going to have the root controller move all of my guys and yet have the group nodes sort of sitting outside the hierarchy, right? Now what I'm going to do is I'm going to take, because the group nodes are involved with the controls themselves, or actually with manipulating the skeleton, but I don't want the animator to touch the group nodes. I'm going to grab these guys. Remember, our group nodes just have our cluster handles in them. I'm going to grab these guys, on a middle mouse button, drag them, and I'm going to put them in the skeleton folder, right? So that should allow us to, freely move this guy and this guy and this guy, right? So I'm going to back up a step and talk to you about why I wanted to walk you guys through this, right? Because last class, when we were talking about rigging the bouncing ball, we had a deformer controlling the geometry. We had a single joint that was parented, that the squash deformer was parent constraint to, right? And then we have our controllers in the geometry. So this lesson, I introduced you to the joint chain. which is something you will use from now on when sort of skinning and setting up your characters. Everything else is the same. The point constraint, the orient constraint, and the parent constraint, and the NURBS controllers. So we built a joint chain for the tail, and I introduced you to the IK solvers. This is the last piece of the puzzle before you're able to jump in and rig a character. The IK solver, what it does is allows you to do bending joints and knee joints and elbow joints without having to rotate each individual joint. So in this particular example, we've got a number of joints for the tail of our character, and it would be a nightmare to rotate each individual joint. So we need an IK solution for that, right? Now, IK stands for inverse kinematics. So the difference between what's called FK, or forward kinematics, and inverse kinematics is this. Forward kinematics means if I want to rotate the arm, I'm going to rotate this joint, and then this joint, and then the wrist joint. I'm moving forward kinematically down the joints. Inverse kinematics means, look, I'm going to create a spline controller, so I just grab that joint at the wrist and move it up and down, and the rest of the arm will sort of follow, right? So you're just moving one thing, and all the other joints are rotating automatically based on some calculations, right? So that's the two ways of controlling joints. Forward kinematics, and with the tail, in this case, would have been a nightmare, and inverse kinematics, where I just need to grab one or two controllers, and it manipulates the whole chain. Now, let's bring back our geometry, right? So I'm going to come in here to the show menu, and I'm going to turn on the polygons, right? There we go. Now, our character is not doing anything with our new little rig, right? So here is where keeping the skeleton separate from the geometry is really kind of crucial. So I can come in here, and I can grab the root joint here, and I can right click and then select the hierarchy. This will grab everything, including the constraints. It should be okay, right? Including the constraints, but really all we want is just the joints. I mean, I've deselected the constraint, but it's not going to sort of attach geometry to a constraint, right? And I'm also going to control click the curve here, because we don't want that included either. And we're going to shift select our geometry, and we're going to just go to skin, bind skin, right? So now, if we've done everything properly, right, we've got the ability to control the character this way. We can also, the joint orientation. I moved the joint orientation off by accident. We can also come into our channel box here, and we can do translates, right? So now we've got that, except it's attached to a joint, right? And we can keyframe that. We've got a little bit more control over it as opposed to the deformer. And we can also grab our tail. And I'll talk a little bit about that actually. This is good that it happened, right? So I've got this. So I have something that I can grab in terms of controllers, and I can animate that tail, right? So why is the ball moving? Well, this has to do with that. Remember that fall off I showed you? So when I did the soft select brush, I said that you have certain vertices in the middle that are more influenced by others, right? So in this particular case, we have the joints in the tail influencing the vertices here, but they also went and grabbed some of the vertices on the body of our little ball character, right? Which we don't want. So what I'm going to do is I'm actually going to bind these separately. Vertex painting, yeah, you can do it that way. There's another way we'll do it, super quick way. So I'm going to come in here, and don't worry if you make a mistake binding, right? Because again, you can always come over to skin, unbind skin, right? Now, what I'm going to do is I'm going to grab a face here on my sphere. Now, there's some hotkeys that Maya comes with that are handy for selecting multiple faces on an object. And that is Shift, left and right angle bracket, right? So I'm holding on Shift and right angle bracket, and it's growing my selection. Cool thing about this is it's going to stop when it hits border geometry. That means it's not going to go and grab the tail, because the tail is a separate piece, right? So I've grabbed all of that, which is cool. And then I'm going to come in and I'm going to, actually, I needed to grab the joint first. I'm going to come in here and grab these joints first. I'm going to shift select the face, right? And I've got all those faces selected. I'm going to go to skin and bind skin, right? So now this is only controlling the sphere. Now we're going to do the same thing with the tail. So I'm going to come in here. I'm going to right click, select face. I'm going to grab that one face. I'm going to shift right angle bracket to select everything. You can just spam the right angle bracket. It'll stop when it hits a geometry extent, right? Then I'm going to come down to where I've got the tail joints. Now that selection's stored, right? I'm going to go back into the tail joints, grab every single tail joint. I'm going to make sure that I'm not, I can grab the end effector, that's all right. And then I'm going to right click on the geometry and select face. So it lights up the faces and it remembers my selection. So I've got the joint selected, then the face is selected, and I'm going to go to skin and bind skin, right? So with that, I can grab this, right, and move it, and it didn't, why did it not grab that? Something happened there. Okay, so we got that, and got that selection stored there, and we're on the tail joint, and it's just that geometry. We did our skin and our bind skin. None of the items can be added to the set. Let me just take a quick look here. Membership. Why? You know what? I don't want to open up the geometry spreadsheet, so I'm going to back up a step, and we're going to keep these guys separate pieces, right? Okay, so I'm going to grab this geometry, and I'm going to unbind it. So how do we solve this issue? Well, the best way to do it, vertex painting is literally painting colors in the vertices, but you can also vertex paint for skin maps and weight maps. You can also vertex paint for selections. That's what it's typically used for, but I don't generally introduce it till a little bit later. So I'll talk about that in a bit. I just need to figure out why we've got this. Okay, so first of all, let me take that controller and zero it out, right? Then bring this guy down. Okay, so here's how I'm going to solve this, right? I'm actually going to go back to the geometry and I'm going to break it apart, right? Now, to do this, I'm going to go back into the modeling menu and I'm going to go to my mesh and I'm going to go mesh separate, right? So here's what that does. It goes and it takes the geometry and separates them to the geometry boundary. So that's how it figures out there's two pieces, right? So if we'd modeled the tail out of the sphere, Maya wouldn't know what to do. But because we took two separate pieces and jammed them together, Maya just scans until it hits the border of one piece and goes, yeah, that must be one piece. And then does the same thing with the other, right? So we can easily go back and say this is ball one. And then we can come here and we can call this tail one. Now this should solve our problems for us. Now, Maya's also saying, look, I'm going to remember what you did for you, right? But we don't want it to remember anything. So we're going to go edit, delete by type history, and then that's gone. And so we've got our ball inside a geometry node, right? But two separate pieces. So here, now, it'll be a little bit easier because I can grab the joints that are associated with the center of this object, and then control select the ball and go back to my rigging menu and say skin, bind skin, right? So this guy will only control that geometry. Then I'm going to grab all the tail joints. Right? And then I'm going to control select the tail. Then I'm going to go skin, bind skin, right? And this will only, there we go. Why is it influencing that geometry? Oh, that's a bit strange. Okay. That's something I'm going to have to go and I think figure out. Because these joints should not be manipulating that body geometry at all, right? So that's kind of unusual. Ew, and frustrating and annoying. Okay. I knew there might have been some issues we would run into, but that's fine because what I wanted to do was cover the theory behind the basics for it, right? So again, it's this idea of being able to use an IK spline to control many joints in a chain, right? And that's what we're doing here. Now the fact that the joint chain is influencing that object is really bothering me. So what I'm going to do is I'm going to right, I am going to solve this, but before I do, I'm just going to and I'll show you how I solve this. Oh. Okay, so before I go in and solve this, I'm going to ask if you guys kind of got the concepts from start to finish. Again, it's this idea of joints, controllers, and an introduction of the IK spline handle. That's all I kind of wanted to cover today's lesson. Now I'm going to dive into problem solving, and I can walk you guys through it if you're more technically minded. But if you don't get the steps I'm going to go through next, you don't have to worry about that. This is a little bit more advanced knowledge in terms of digging into it and trying to solve a few issues. Yep. Yeah. So I'm streaming this for a reason. It is quite complicated to set up. And it's one of the more simpler IK controls, right? But it gives you a taste of it. Now, our controls are working fine. There's only one issue we have here, and that's the skinning information, right? So I'm going to grab these two guys, and I'm going to go to skin and unbind the skin. It should pop back to normal. Yeah. Okay, so I'm also going to, again, edit, delete by type, history. I'm also going to, oh, the data is not a numeric string value. Is it? That could be it. Delete by type, history. Let's go to the individual objects and see if that works for us. Edit. Delete by type, history. Is it because I was trying to delete history with both of them selected? Now that seems to have done it. I'm also going to take it out of this group node. That's making me nervous, that one. Okay, so I've got the geometry menu item, and I'm going to grab the ball. That's all right. Mildly distracted, just staring at the screen. Now I think I've got a cleaner piece of geometry. Now this is something to be very careful with, right? Making sure there's no additional data on your geometry. So let's try this again. I'm going to grab the joints here, and I'm going to control select the ball, and I'm going to go skin, bind skin. I'm also going to grab all the tail joints. Ooh, I know what it is. I know what it is. It's so simple. My God, It's behaving properly, but I grabbed the root joint that's buried deep inside the sphere. So no wonder it's pushing the sphere. I'm going to grab these joints here. We'll skip the root joint because we can do that. I'm going to grab those joints, right? And then I'm going to control select the tail. Hopefully we caught it. I'm going to go skin and bind skin. And no, it wants to follow those joints. Why does it want to follow those joints? Let's see if we can figure this out. We also have a problem called inherited transforms, where the minute I grab a manipulator here and go to move it, boom, the whole joint chain leaps forward. So that's something I'm going to have to investigate as well. Okay, I'm going to back this up. So I thought I found the solution, but that doesn't seem to be it. So I'm going to grab this guy, right click, select hierarchy, shift select this guy, and then we'll try skinning it this way, see if we have a difference here. Nope, still a bit of weirdness. Now what I was going to do is investigate the vertices on this object. So here's how we do it, right? So I'm going to come over here and go to vertex mode. Whoops. Oh, speaking of painting, let's come out of here. And I'm going to go to vertex mode. I'm going to grab a bunch of vertices. And I'm going to shift right angle bracket to select all of them. Then I'm going to go into my Windows, General Editors, and Component Editor. So the Component Editor, what this does, and again, if you're just barely hanging on, you don't have to follow this bit. But for those who are more technically proficient, let's say we want to find out exactly what each individual vertex is doing and what the joints are doing. The component editor gives us a spreadsheet where we can check that out, right? So I'm going to go into the smooth skins and I want to see which joints are manipulating my vertices. So check this out. If I come over here, you can see that I've got root 1, joint 2, effector 1. Effector 1, joint 2, and root. But I've got these other joints controlling things. I don't want that. So I'm going to come over here. I'm going to grab joint 4, which is in the tail. Go all the way down to the bottom of the list and shift select all of those. And I'm just going to type 0 in. And it just forces 0 onto joint 4 and removes it from that solution, right? So we got the same thing with joint 5. Joint 5 doesn't belong there either. So I'm going to grab the top of it, scroll all the way down to the bottom, shift select joint 5, right? Type in 0, which will zero out everything. And that's gone. And lastly, we've got the tail. And so for the tail, I'm going to grab the first one. And I'll go all the way down to the bottom, shift select the last, hit 0, and that's gone as well. So now we've got effector, joint 2, and root 1 controlling our body. Root 1, joint 2, effector 1. Yep. So that is effectively cleaned up. Now I'm going to check this out by going here, grabbing this, and moving it. There we go. Now only the tail is moving. Yay, problem solved. We still have that weird jump. There's an inherited transform in there somewhere. Ah, you know what it is? Check it out. When I originally made that tail, it was over here, wasn't it? And I didn't delete the history on it before I jammed it into the ball. So that's what's going on. We're relatively close though. I mean, this is animatable, right? It's not too bad. The tail does something funny. I'd want to go in and clean that up later. But we can get some nice tail shapes on this, right? That was a lot harder than it needed to be. I ran into a couple of things that I wasn't expecting to. But hopefully, again, when you play this Twitch stream back, you'll be able to walk through and see all of the different steps that I've done, right? And kind of understand the process behind it all, right? So again, the whole idea of this lecture was to introduce you guys to bone skinning, as well as sort of introducing you to IK solvers, because we will be playing with them in depth going forward. This is how we set up characters for animation. Now, typically, rigging takes a fairly long time, right, to rig a character. So I remember working with this guy, Frederick, and I was blown away that he rigged a character for us on Skate inside of 2 weeks. I'm sure times are faster now. You know, there are a lot of hotshots out there in the CG industry. Probably got it down to a week. But yeah, generally 2 weeks. I was working with a guy named Paul Thuriot, who was one of the lead riggers or character artists for the Hellboy movie, the feature film. And so he first introduced me to this concept of broken hierarchy rigs, which I'll talk to you guys about later as well. And also, he generally took like a couple of weeks to rig a character, right? So that kind of gives you a time frame of how long it takes to actually set up a character. Most students, their first time setting up a complex character rig, usually about a month, right? So that kind of gives you an idea of what's involved. Now, you saw how complex it was just adding a tail to our bouncing ball, right? More edges and polygons increase the cost of the model. Yep, it does. I was taught before to create objects with using as few edges, faces, and vertices to achieve the same look of a model and be more cost efficient. Not sure if that's correct though. It is correct. It's an older technique. I'm guessing blend shapes take a long time. No, blend shapes are easy to implement technically. What takes a long time is sculpting the blend shapes. So if you imagine a face, right, and you're creating all the expressions for the face, it's literally like resculpting the face 5 or 6 times, or however many blend shapes you want to use, right? Can you recommend any free tutorials to check out as well as this lesson? Yes. I wonder if Javier still has his website. Javier might still have his website up. Let me check it out. There's a Vancouver technical artist I worked with named Javier Gooch, I think his name was. And he had this website, Rigging 101. Let me just do a search on, maybe his website's not up. Rigging 101, there it is. Right? Oh, just that. There's his website. Yeah, Javier Solsona. Yeah, his nickname was Gooch. Javier Solsona, he's an awesome rigger. He's super fast, but the one thing I liked about working with Javier is he makes a lot of complex rigging concepts very, very simple, right? There's also, I'll put this website into the chat. Now, I don't know how, like, his stuff is really old, though. Yeah, I don't know if it doesn't look like he's updated it. The other person is TJ Gelda. It's another buddy of mine. He's got some books that he wrote, self-published. So basic character rigging, beginner character rigging, hardcover, right? He's got some wonderful tutorials. So it's a book that I highly, highly recommend. TJ Gelda is now senior product supervisor for the animation team at Autodesk Maya. So any feedback will influence his decisions in terms of what gets put into Maya and what gets taken out. So yeah, TJ's awesome too. He's a really good teacher as well. So he makes the concepts quite clear. Right. Let me pop these two in here. If you guys run into any rigging tutorials and you're not sure if they're any good or not, just send me a link and I'll tell you, yeah, go ahead, follow this tutorial, or no, don't follow this one. You're going to learn a lot of bad habits, right? So, oh yeah, and there was an earlier question I wanted to answer about, for detailed modeling, right? So there are 2 schools of thought, right? Low poly modeling, which is rapidly vanishing, right? Where you're modeling and creating and you're thinking about your poly count and you're optimizing as you create. Myself and a bunch of my colleagues were against this when I was at EA, around about the time of the first Need for Speed Underground. So we formed a character group at EA where we discuss it. And we came up with this concept of the retopology workflow, which we started putting in place straight away. Now, the retopology workflow says when you first start creating a character, grab ZBrush or Mudbox and just sculpt your character to the best of your ability, right? Make it as detailed as you want. Just go to town and focus on being an artist. Then when you're done, retopologize it. In other words, what you basically do is you trace over top your high-res model with low-resolution polygons, and then you do a detail transfer from one to the other. And then you got your game-friendly character. Now, the reason why this, in my opinion, is a better process is that when you're creating your character, I need you to be an artist first and foremost. If you're an artist, you're making nothing but creative decisions. But if you're modeling and optimizing at the same time, that's not good. I used to model like that. That's not good. Because you're jumping from being creative to, okay, I got to problem solve this, to being creative to going, okay, this is too many polygons. How can I optimize this? And you're making very, very bad artistic decisions based on the rational part of your brain, if that makes sense. As well, it's a lot more fun to just sit back and sculpt fantastic looking characters, right? Now, the retopology workflow has become so popular that if you go onto ZBrush Central, you'll see these amazing sculpts and amazing kind of game-friendly versions of these sculpts. Anybody who's actually good works that way. Now, it takes a lot longer because, again, you're effectively modeling your whole character twice, right? So there are those out there who can model with polygon count in mind, but that talent is very, very rare. And for me, from a personal point of view, why would you want to, right? I'd rather just jump in and model a fantastic looking character, and then retopologize it from there. Hopefully that answers your question. You do eventually get to the point where you're sort of doing a bit of both, right? Because if you've been working on digital characters for a long time, you can't help but think about deformations while you're modeling. It just becomes part of the package, and you, at a subconscious level, you are hyper aware of it. But I'd rather you guys focus on being great character artists first, and then we'll talk about optimizing the geometry for Game Engine second. Having said that, I don't want to see a simple sort of SpongeBob level cartoon character that clocks in at 8 million polygons, please, right? So you got to be a little bit of aware of where you need the detailing, right? So does that make sense? Okay, that is all I wanted to cover with you guys today. My apologies for the tail rig not quite being up to spec right out of the box. What I might do is I might sit down and investigate where that parenting issue went wrong. Now, I will end by saying this. Rigging and rendering are the two most complicated areas of 3D. Complicated. The easiest being architectural modeling, right? So if rigging's complicated, it's complicated for a reason. There's a huge reliance on the underlying mathematics, but you don't have to learn mathematics at all. It's just you got to be sometimes a little bit aware of it, right? i.e., you got to make sure all of your stuff is zero-outable. You also have to be sure that there's no values on the scaling because unpredictable things will happen. Unpredictable things that might haunt you is this. You just want to move up and down, but the tail kind of jumps forward. Like, where did that come from? There's a value on that joint chain somewhere that I wasn't aware of or didn't delete properly or clean up properly. Otherwise, this tail rig would have been perfect, right? So and rendering is the same way, because rendering takes everything that you've built in your 3D scene, all the lights and the cameras, and runs away and does a whole bunch of mathematical calculations and spits out a beautiful full color image, right? So you can imagine the boatload of maths that go on when Maya's run off to do some rendering, or Arnold, or what have you, right? So again, those are the two most complex areas of CG work that I find. Well, I'm discounting the whole visual effects, particles and fluids and all that kind of stuff. But for you guys, in terms of just straightforward modeling, rigging, and animating, those are the two areas that you'll encounter first that are technically complex. I blame my old modeling teacher. He taught me to optimize when modeling. I find low polygon modeling more free-flowing. Yeah, I'm not saying one is right or wrong, actually, because the sort of optimize while you go modeling is still very much a valid technique. Like I said, we used to do it back in the day. I just don't prefer it. Now, it's interesting because when I introduce you to high poly sculpting, I'm going to hypocrite myself because I will teach you guys that you got to take your polygon character, your low polygon character, model as much detail as you can, then go up a subdivision, then model more detail, and then go up a subdivision when you've utilized all the polygons you can at that level, and so on, right? So it really kind of depends. There are other times where I'm just going to throw a piece of geometry into ZBrush, up it straight up to 4 million polys, and dive right in. It really kind of depends. I worked on some character modelers for Ben 10 DS. That game, I was straight away in low poly mode, right? So I was just optimize as you go. Because there's not much you can do for the Nintendo DS, right? So I don't think I had my artist's hat on at all. You don't need to take the Ben 10 character into ZBrush and sculpt it and then retopo it, right? So yeah, it just sort of depends. One of the things that I can say that unifies both techniques is being polygon aware is good. It's a good thing. Yeah, I find I can be more creative starting with low polygons because I get very OCD with high poly detailing and modeling. Yeah. Other people equate it to this, right? I start off with thumbnail sketchings, then rough sketches, then my detailed sketch, right? So that same process, that same creative process can be utilized when you're doing low poly modeling to high poly modeling. So yeah, there is no right way. Yeah, very similar to the way you draw. Yeah, absolutely. There's no right way. All I'm saying is that me and a collective of character artists, Electronic Arts, we prefer just sculpting digitally, straight off the bat. Not encumbered by technical considerations at all, right? However, I say that, but we also had the discipline of having all gone through low poly character modeling first. So we were, to a certain degree, hyper aware of polygons and what they do. So maybe it was easier for us to jump into high poly modeling. I don't know, right? Is that more for industry standard modeling? Yes, I would have to say yes. I think it's more prevalent now. It's rarer and rarer that I run into a modeler who starts off low poly modeling and optimizing as they model, right? I think I've run into way more digital sculptors. Right? If you want a good sort of, what was that artist's name again? Oh, there is a good kind of in between, I think. Example would be, let's see. The making, is it Paul Tosca? Yeah, okay. So here's an example of a good kind of halfway point, right? This modeler is a very good low poly modeler, right? And he walks through his process from concept art up, right? So you can see this particular modeler can really utilize low poly counts and create just a beautiful amount of detail. So industry standard, would I hire this guy if I was putting together a character modeling team? Yeah, absolutely. Would I force him to do digital sculpting first? No. Right? In fact, actually, you'll find, it's interesting. You'll find that a lot of art teams in games and studios, there's a bit of flexibility, right? So there's a little bit of support, well, depending on your art lead, there's a little bit of support for your process, right? As long as the outcomes look phenomenal and they can run in game, right? There's a lot of facilitation for your process. Even software, right? So when I was at EA, I could request software and they would make sure that I got it like right that afternoon, right? They were really super fast with that, right? So I love creating models in wireframe as well so I can see faces on the objects. Yeah, some people like that. I personally don't, because I like to get in and really sort of craft the facial expression and just get right in like I'm looking at digital clay. In fact, it probably has to do with the fact that I was a clay sculptor before I got into 3D, right? So that's probably had a huge influence on me as well. So the fact that I can work with digital clay is just a little bit more, I'm just a little bit more receptive to that technique. Yeah, you can approach modeling a little bit more mathematically, but I'd be very, very, very careful, right? Because the first thing that we are after, if I were to art direct you or be your art lead, the first thing I'm after is a character that emotes, right? I would rather have a character that emotes, that leaves a lasting impression on the audience experience before a model that runs safely at 60 frames a second, right? That doesn't matter to me, because I can always take a character like this character that straight away, has this sort of visual impact, and I can always optimize it. Like anybody can optimize. In fact, what I would probably do is if you were a really good digital sculptor, hire you as a senior and set you up with a junior, right? To allow you to digitally sculpt or create however you wanted, and then get the junior to cut down your geometry for you, right? So there's a lot of pipelines that work that way as well. But it really depends on what gets the most creativity out of you. And what, again, results in a character that has this emotional connection, right? So let's take a look at just gonna pop this up real quick because they should have. Right, so if we're looking at something like this, right? I'd rather not have you not focus on mathematically creating this moment. Do you know what I mean? I just want you to create a beautiful piece of art, and then we'll figure out how to optimize it to get it running in game. Now, the process is not that linear. Again, I have to say that again, right? Because a lot of high-end modelers that are worth their salt are polygon aware, right? So it's not like go to town and do a 16 million poly character that nobody can use, right? So there's a bit of a balance. And you do tend to jump back and forth as well, right? It's all about capturing the best, not necessarily the best approach, but one that capitalizes on the most creativity, the most passion, that gets characters that emote with the audience, right? So however you get there that's the key. Don't worry about it getting it running an engine or getting your render times down. There's always time for that, right? Well, just barely, but there are always times for that. Render optimizations will happen. No matter how careful a modeler you are, they will always ask you for geometry cut downs. If you understand that as a rule of law, you will be safe. They will always, always, always ask you to cut down your geometry. Whether it's a 1 million poly character or a 100 poly character, they will say, can you make it 99 polys? Right? So. Yeah, cool. Yeah, I would never limit myself to achieving a lifelike model. Yes, that should be the goal, right? And really, how you get there doesn't really matter as long as you get there and it looks phenomenal. Yeah, you can be aware of getting rid of excess polygons, but if it gets in the way, if it breaks you out of the vibe of creating your character, forget about it. Don't let that get involved in your process of creating a fantastic character, right? If it does, cut that from your process because it's distracting you. If you can balance it, so your model, and I do this as well, so I'll model and I'll go, oh, I can't do that because that's too many polys. But then I go back and I'm modeling, right? So I'm just sort of, I don't even say it out loud. I'm sort of subconsciously aware of it because I've been doing it for so long. So that's where you want to get to. That's the best way to look at it. So your conscious brain is sculpting like an artist, and your unconscious brain, your subconscious mind, is keeping an eye on the poly count. That's where you want to be, I think. Yeah, cool. There you go. Perfect. Okay, I will leave it at that. I think hopefully you guys got a lot out of today's session. I have never successfully taught a rigging lesson without something going a little bit haywire. So that's sort of par for the course, I think. That is, we are at 3, and we've gone 3:44. Okay, so we've gone 45 minutes over. I will bid you guys a fond farewell, and we will catch you guys later. Yeah, I know I might actually repeat this lecture next week as well, just briefly, hopefully with some tail fixes for you guys. And then I think the rehash might help you guys a little bit. So we'll go through it again, right? Okay, I'll talk to you guys later. Cheers. Okay, so that is that. I can't believe a simple tail rig didn't quite work out for me, right? So the whole idea of using clusters, that's been around for a dog's age, right? So you always have to cluster. Anytime you use a control curve, you need to have that cluster so that you can constrain things to it and control it in various different ways. I think the biggest trouble I was having, actually, other than the joint chain jumping, right? There's negative translate. You know what? There we go, right? So if we zero this out, will it jump to, if I move this guy, where is that located? No, it's not there, but it's picking up transforms from somewhere. So I need to figure that out. I suspect maybe it might be on the group node somewhere. I'm not entirely sure. So I'm going to double check that and then see what's happening. It should be a fairly straightforward rigging thing. I'm at a loss as to why with a separate piece of geometry or facial selection, or faces selection and the joint chain selected, I was skinning and it was still picking up vertices on the sphere. That was a bit strange. So I'd never run into that before. But whatever, I'll figure it out. And then we'll try this stream again and try and sort it out, right? Because for me, it's really important to understand how the IK spline tool works, because you use the IK spline tool a lot, whether it's you got rope swings or things like that, or mouse tails and all kinds of other stuff. It's a really handy thing to understand. And then when we move to the standard IK rotate plane solver, then we really kind of need to know the basics of what's going on in this IK spline. So we'll leave it at that, and I will talk to you guys later. Thanks a lot.